Today we will be working on an AP Calculus AB practice test from 2015, question number 6. But before we start on the actual AP question, we will do a review. So here's a question. This is from section 2.5, and the question is, find dy dx by implicit differentiation and evaluate the derivative at the given point. This is the equation, the problem. xy equals 4 at -4, -1. So the first thing we have to do is differentiate the equation. So the derivative of x is 1 times y, plus the derivative of y is 1 dy dx times x equals the derivative of 4 is 0. So you have y plus x dy dx equals 0. You want to isolate your dy dx, so subtract y on both sides, and then divide x on both sides. Now that you have your derivative, all you have to do is plug in your coordinate points. So you have an x of -4 and a y of -1. And you just plug those in. So your dy dx equals to be negative times -1 over -4. And that is -1/4. For our next review, this is number 45 on section 2.5. Find the second derivative in terms of x and y. X squared plus y squared equals 36. So let's find our first derivative first. So that's 2x plus 2y dy dx equals 0. Isolate your dy dx, and you get 2y dy dx equals -2x divided by 2y, and dy dx equals to be -x over y, because your 2's cancel out. So this is our first derivative. Next, let's derive it one more time. So you can do the product rule. And so the derivative of the first times the second minus the derivative of the second times the first. Don't forget the dy dx because you're deriving y instead of x. All over the second squared. So that equals to be, let's simplify it, -y plus x dy dx over y squared. So to solve the rest of this problem, we have dy dx here. All you have to do is plug it in. So -y plus x, and dy dx is -x over y squared. Next thing you have to do is just simplify it further. So you want a common denominator on top, so you multiply this by y over y. So it's -y squared over y plus -x squared over y all over y squared. And all this is just multiplying by 1 over y squared. So it's -y squared minus x squared over y times 1 over y squared, and that equals to be negative y squared minus x squared all over y cubed. You can actually simplify this even further. If you factor out a negative 1, you'll get an x squared plus y squared over y cubed. And if you look back to our original problem, x squared plus y squared equals 36, so you could just plug that in for this part. And you would get negative 1 times 36 over y cubed. And your answer would be negative 36 over y cubed. And that is your second derivative in terms of x and y. And our last review problem is number 57 in section 2.5. Find the points at which the graph of the equation has a vertical tangent line. 25x squared plus 16y squared plus 200x minus 160y plus 400 equals 0. So the first thing you should do is derive it first. So you would get 50x plus 32y dy dx plus 200 minus 160 dy dx plus 0 because it's constant and it equals 0. Next thing you have to do is isolate dy dx. So first subtract 50x and 200 so that you can get it on the other side. So you would have 32y dy dx minus 160 dy dx equals negative 50x minus 200. Now you want to isolate dy dx, so factor out dy dx here. So you can divide 32y and minus 160. dy dx times 32y minus 160 equals negative 50x minus 200. Now all you have to do is divide 32y minus 160. And that's your derivative. So dy dx equals negative 50x minus 200 over 32y minus 160. And now we're looking for a vertical tangent line, so your slope has to have a 0 for your denominator. So all that matters is your denominator. So, and you want to know what y has to be for that to be 0. So, (32y minus 160 equals 0). Isolate the to find your y, and y would equal 5. And since it's looking for your point, you want to find x2. All you have to do is plug that 5 into your original equation so that you can find your x point. So 25x squared plus 16 times 5 squared plus 200x minus 160 times 5 plus 400 equals 0. So you'd still have 25x squared. 5 squared is 25 times 16 is 400 plus 200x. 160 times 5 is 800 plus 400 plus 0. 400 plus 400 is 800, and 800 minus 800 is 0, so those cancel out. and you're left with 25x squared plus 200x equals 0. And if you factor out a 25x, you would get an x plus 8 equals 0, and then to get 0, your x would equal 0 and negative 8. So now that you have your x and your y, you can find your coordinate points, and so your coordinates would be 0, 5 and negative 8, 5. And those will be the points where there is a vertical tangent line.